Yep.
Cool. All right. I'm lucky enough to be invited to this great place. Thank you very much. To talk a little bit about what we do at Databutton. Now, Databutton is a startup here in Oslo. We've been around for about 3 years. I was going to rush through this in about 20 minutes. Last time I did a live demo, but I don't think time will allow it today. But basically, I'm going to quickly talk about what Databutton is. We do a bunch of code generation. That's what we do. We build apps and stuff on behalf of customers. And a little bit about how we do it, since this is a meetup for founders and engineers and technical people. We're going to dive a little bit into what we've ended up with. And then, since we've very recently changed our main base models from GPT4o into Claude 3.5, we're going to go through a little bit of benchmarks and some learnings from that period right there. And then a little bit about what now, what next. Real quick, just to set some context, the company called Databutton, 3 people started it. I'm one of them. We're all from Cognite. I think I saw someone else from Cognite here too today, earlier maybe. We started in September 21. We've raised about $5.5 million from European VCs. We are 7 employees, all sitting in Oslo. We pivoted through existing customers that we had in summer of 23, when we thought that ChatGPT was going to change the world. And then we had our first paying customer on Databutton as it's known today in January this year. So the last time I had a chat here, I think, was about, February, March or something. So we were in the very, very beginning of our journey, and we didn't know anything, very similar to where we're at today. But we have some more data to bring, because we've been lucky to have quite a few people testing us, trying us, paying for us, being happy, unhappy, and so forth. So Databutton, the product, is today a platform to generate full-stack apps. So that means that front ends are written in React, backend is written in FastAPI Python, very similar stack to what we use internally. It's a fully online workspace, similar to Codespaces and otherwise, where you can build the whole thing in the browser. It has first-party integrations with auth and payments, meaning that people build primarily SaaS type of applications with logins and Stripes, and people pay, and a lot of micro SaaS and tech startups. And you can also deploy with a single click to a custom domain. Who generates apps? We didn't really know this. Everyone thought that everyone was going to generate apps. Developer was going to get our jobs. That hasn't happened by far. After running with this for about 8 months, we've seen that we've gotten basically 3 cohorts of people that are paying for Databutton today and other similar type of services. Some of them are thank you. Some of them are building MVPs for first customers. That's the tech startup segment, typically non-technical or semi-technical co-founder, not fully code proficient. They typically apply to the Antlers and startup labs of the world, and they use this to either get their first 100 customers, their first co-founder, their first money, that type of thing. We also have startups that are struggling to scale. So we have a couple of Series A startups who is struggling to do deliveries that they currently have. So they build embeddables and small iframes that they put here and there into their products to basically expand engineering. And then we have SMBs who are mostly non-technical type of people who are interested in trying out new ways of basically generating revenue for their business. That might be hairdressers wanting some loyalty programs. It might be here there's interior design people who want to be able to prompt up your own wardrobe and use the new levels of technology to basically get the cost down in speccing. And largely there are agencies and consultancies, which is probably the biggest group to date, which is desperate to get margins down and margins up and basically make more money per sale. So we do code generation. That's basically what we do. We spend about 140 million tokens a day on various LLMs, and all of that is going through generating code in one way, shape, or form. Typically, when people think about code generation, they think about asking Claude for help in their existing project, to use Copilot or to use Cursor SH or some similar type of developer-centric one. None of the customers, none of who's are paying for Databutton today are developers. They're typically systems engineers, or they have a background working in software companies, maybe in marketing, as a PM, as a designer. They're proficient with the fact that there exists a backend. There's a thing called an API. There's front end, but they're not code proficient. So LLMs today are excellent at writing single scripts, small shell scripts, small Python script, notebooks, all that kind of stuff. It's difficult once you start to generate bigger apps that's going to live over time. You start to accrue tech debt. You start to think about dependencies is going to grow. You're going to have to update your stack. You're going to have a good CI/CD pipeline. You're going to have to be able to do proper rollbacks. You're going to have to do measuring, monitoring, all that kind of stuff. So this is our world. This is what we do. And to facilitate this, we have a product which looks something like, maybe I should just really quickly jump into something like that. So this is how it is for a user to be inside of Databutton, where they have their app in the middle. They have chats with threads and whatnot from as you're comfortable with. And then there's, similar to React app, there's pages, there's components, there's APIs further down, and there's databases and everything you need to basically ship a full stack app. And there we go. So in that workspace lives both a human and an agent. And they're meant to basically collaborate to ship real full stack apps that they, again, make money on. And so it has all the stuff that a normal developer or a normal kind of consultant type of developer would have. They have code editors, all the tools available they need. And humans sit in here like a regular human, and they want apps and want features and they want bugs fixed and whatnot. And then the agent is also in there and has a bunch of different tools. And this is how our world looks, where we have a set of agents which has a bunch of different tools to plan and debug what it's going to do, to parse requirements, to research the web, to write code, to write tests, to use secrets, to test databases, and all that kind of stuff. So we are writing a shit ton of tools. That's kind of the developers at Databutton's gig. Write good tools and good tests and basically benchmarking protocols for this. And many of these tools, again, I'm sure there's many people here building with LLMs. And similar to you guys, each of these, or the more complex of these, such as writing code, or analyzing images, or researching the web, is again an agent, which then kicks off another agentic workflow so that you maybe use some other model to do some other tasks, which might be cheaper, or faster, or more expensive, depending on the complexity of the problem. So to get a little bit into the weeds of how we think about a simple commit seen from the user's point of view. A human would say something in the chat. So everything is done currently by chat. That's the strength or weakness of the current paradigm that we're living in, where they would come with some feature request or some bug fix and whatnot. And then the agent would run off on its own. And the entire loop would take typically from 30 seconds to 2 minutes. And then it's going into a planning phase where it will read different code throughout the entire repository and get what it needs. It's going to write a detailed change request to a set of agents, which are developers. And those developers goes into tech mode, and they think and they plan and they write a test and they write the necessary code to execute what they need. It runs all kinds of linters and dev tools and all kinds of stuff and reads logs and get back what it needs to do this properly. And then there's a third agent, which is a reviewer, which is more of a pull request reviewer for those who work in developer teams, which will then take the original feature or bug, look at the process and look at the resulting code and evaluate whether this is valid and good enough to end up in production. And if it does, then everything is good. The app updates and the user continues to the next feature. If not, then they retry. Which means that this basically is at least like 4 LLM calls to do a single commit. At least 4 LLM calls. And average context is probably around 30, 40K, I think. So this is how every single code update is done in Databutton. And it's really slow. It's very slow. Tokens are slow, ChatGPT is slow, everything is slow. So as we progressed with this, we needed to think about how we could do it faster. The main intent for me to lay out all our secrets and everything we know about this is so everyone can tell me that I'm wrong, that I'm stupid, that there's much better ways and cheaper ways and faster ways to accomplish the same thing. And we'd love to hire or work with the people who think that is true. So basically, continuously producing the entire code is really slow, quite stupid, very expensive. The maximum amount of tokens you can generate from an LLM call is about 4,000 tokens on the state-of-the-art models today. That holds for both Claude and GPT4o. 4,000 tokens is roughly like 300-400 lines of React code. That's like a medium-sized React component, I would argue. So in order to make this better, we need like a different type of approach to think about this. First and foremost, get rid of all the errors so everything goes on the first retry. But then we get into the world of patching. which is how the world of Git is built up, which is how no human in the world writes their code, but it's how most people review code. So basically, in the previous example, when we're adding tooltips, there's not really a lot of code that needs to be changed. There's a few fields and a few different developments, maybe some imports, maybe some library, maybe something that needs to be used, but out of a component of 600-700 lines of code, there's maybe, 50 lines at most that you need to write? So we have tried to get all these LLMs to basically produce various forms of patches or search and replaces, or where you would say between line 300 and 350, you should replace this with that. And then we've geared up with reviewers on the other side to try and keep this consistent, which can dramatically reduce the amount of code that we need to generate and dramatically increase the speed in which it takes to get through the whole pipeline when it only needs to produce 50 over like 500-600 lines of code. And the early models were really, really, really shit at this. But the new models are starting to get quite good at it. I think there's about maybe 10 companies that I know about that is doing similar stuff to us, and I'm not counting the Copilots and the Tab9s and the in-editor things, which is more of an autocomplete and more of let's say, they work with a significantly different context window than you would do when you work on a full app. You've had attempts of Copilot having Copilot chat, which is have like quite all right results, I guess, when you can like control the context yourself. But there's only so many people that are doing this, and a lot of them are collaborating in one way, shape, or form. This is a very common thing, even though LLMs are very smart, they can't really understand line numbers at all. And there's heaps of different strategies to accept like lazy patches. I'll show a little example just to drive the point home of LLMs being actually really, really stupid. If I take this little code file, which has 230 lines, and I give this to one of my best friends, ChatGPT, and I ask them, which line is this found at? Let's see. On which line is this defined? If I do this, it just blurps out an arbitrary line number, 150, and it's on 160. So patches, which typically revolves around line numbers, is a really inefficient take to do on this. Although, similar to humans, we can instruct this to be significantly better. A very inefficient, but a very robust mechanism is to do something like this. So this is a surefire way to get it right. Asking it to print out every single line of code and count them, and oops. Wait. Maybe let's say, write out every line, then stop when you find it. There we go. So this is a typical way for people to do it. And then there's a million different ways for people to, there's prompt golf games online where you can get comfortable and do this type of things to make it do like chess puzzles correctly, because then it would easily like miss taking the queen because there's some other stuff in the way. And this is like tons of mechanisms to try to do this on lesser tokens. So we do competitions and stuff on this internally to try to like break these types of problems in like simple ways. But I think most notably, the newer models are getting more and more like significantly better at this. So we have started to, so we basically do our version of patches. So we have gotten different LLMs to produce different type of patches and different type of patching strategies. So we tried to train it up to do git diff patches. We tried to get it to do like udiff patches with and without line numbers. We tried to do search and replace and all kinds of stuff. And then this is one example of something, of an actual commit that's gone through Databutton today at 3. So this is using Sonnet, and the typical here is how it looks This is what the agent has rewritten from the user to get it into like a spec format. So you want to add a secondary button, yada, yada, yada. And then what it's doing is that it's basically, if I look at the diff, it's only changing these lines, which means that it can get away with producing, what, maybe 15 lines in total, instead of reproducing the file, which is about 300 lines long, I think. So you can see here is the type of patch that it chose to write. So here it gets away with writing maybe 40 lines of code, and then the reviewer will look at it after and say that, oh, looks good, secondary button, yada, yada, yada. And then this is then tuned, of course, to be, this is a pipeline, so this is kind of tuned to be cohesive, if that makes sense. Does anyone else have experience with generating code in any way from an LLM?
Include the line number in the prompt. Like, wouldn't that fix it?
No, you would think so, wouldn't you? Unfortunately not. Really?
About you generate the line before and after.
Come again?
If you generate, like, you need to insert it between two lines. And
Yes.
you can ask it to produce the code, the line before and after.
Yes.
Does it work?
To produce lines before and after.
And then find where the line starts.
Yeah. So what we do today is basically what you're suggesting, I think, is that we're doing some sort of, as you can see, the patch format that I showed here, this one, the patch format has what normal patches has. It includes a set amount of lines prior to where the change should be, which could basically then function as like a search and replace of the before and after. Yes, absolutely. Yeah, so basically we've ended up with doing patches. We think it's more efficient. For those who are really interested, there's an open source project called AderDev, which is a really, really good like Copilot type of coder who's pioneering a lot of this stuff, for those who wants to go even further. And then, this is where we're at August 8th, prior to the change. So this is 1 day of sampling. So we sample about 10% of all the requests and the commits, basically, that our agents are asked to be doing. I realized this was not the best lighting, but it says here that like 36% of the time it goes through on the first attempt. And it fails during review, meaning it wrote legal code, but it didn't satisfy the request from the user. Whereas 36 is basically ChatGPT burping, or like some way, shape, or form produces a patch that's not working, code that's not able to be searched and replaced for, can't find line numbers, what have you. But then we took a stab at Claude starting just after, after the summer-ish, just to benchmark it on the exact same thing that we already did. And we went from, on the same data set, same code, and same reviewer. So the reviewer was stable to be GPT4o. And it basically went from a 24% success on that data set to like an 86% success on that data set. And for those not familiar with it, Claude Sonnet is actually, or was, cheaper than the previous 4o model. Now they're about the same. So the newest GPT4o is $2.50 per million tokens. Claude Sonnet 3.5 is 3. So it's basically the same. But this is a game changer. And around this time, you'll see Replit, you'll see GPT Engineer, which is a similar type of company from Sweden, all changing to Sonnet. Turns out that Sonnet is like hyper-tuned to coding specifically, which is really neat for people like us. Sonnet. Yes, sir?
There have been a lot of reports on Twitter recently that Sonnet's quality has gone down.
Yeah.
It's a bit cyclic.
Yeah.
Observe that?
Yeah. So it's the same with, so I think that the closed source providers, I'm not convinced that you actually just get an LLM. I think you get more of like a product, meaning that they probably reformulate the input or they keep changing the system prompt or whatever. Like you're not in control of the whole thing. This means that the models is constantly drifting. It's a horrific space to build in. Once you start to get volume, like it's really weird, man. Like you see that one day you have like everything is great. The next day it starts to act completely different with the same system prompt type of thing.
Jesus Christ. It's a nightmare.
Yeah, it's pretty fun though, isn't it? Yeah, so basically when we started doing this transition, for those who are building with it and not using some type of like layer in between, The APIs are also still shit. The APIs change all the time, require parameters, pop in. So like it's difficult to build in this space. You constantly you see like changes to the infrastructure, both in GPT and in Claude. When we started testing this, we started testing it through a service called OpenRouter. I think there's an Oslo competitor that we should have used instead. That was said last time, but I don't remember the name. I tried to reach out and find them, but we used OpenRouter. They're basically a open AI SDK which can talk to any model. And they put like a 5% margin on top. So for experimenting, it's great. If you're going to have volume, build it yourself because it's very expensive. The big differences between Claude and GPT4o from our point of view is that the code is like more often correct, meaning like the semantic code, the logical code. So there's lesser bugs. It actually fulfills the request at a much higher rate than GPT4o. And it's much better at consistently producing the right formats, which is what GPT4o is struggling the most with. Price is a little higher, but they react to prompt and workflows very differently. The same prompt in GPT4o versus the same prompt in Sonnet 3.5 produces vastly different results. The way they operate with tools is very different for those who's dealing with that. So it took about like a week of pulling hair to like get it into shape. Then we shipped it. Then we realized we weren't in shape, so we're still fixing everything. And I think for those who are into solving more complex problems with the likes of GPT and Claude, you're probably also already into the whole thinking and planning steps and the various prompt techniques that exist and the chains of thoughts and the React models and all that kind of stuff. And from our point of view, at least, that is just like two completely different things across different LLMs. So this is now the current benchmarks. So this is then from August 19th, where we've had around a day. We sampled 1,000 commits at a 72% success rate in the first go, which is really good. And here was like 640 on like 36. So it's like a significant, almost twice. It's more than twice as correct and a little bit faster and a little bit cheaper. So if you haven't already experimented with Sonnet 3.5 and you're doing code, you should. As we changed it as we started to shift our traffic over to Claude, which happened around here, internal testing, shipped it to a set of, in the first tier list of our like future flag release. And then here we're on tier 4, which is the highest tier of Claude. There is no higher tier than this without talking to sales. And I don't talk to sales. And so what happened here is that we got rate limited on the dot, so we weren't able to use it. So we had to swap everything back to OpenAI for like 24 hours until support came back and said, yeah, absolutely, you can pay us more money, that's fine. But basically, it made me think a little bit that maybe not too many people are using Claude, which is a bit scary to think about. Basically, in order to get there, you have to be on a custom plan. This is like a thing. It's like a thing. OpenAI, you can just like blast all the money. Doesn't matter. They just take everything. So where are we now in Databutton? We've built this thing for 8 months. And things are still like super unstable. Everything is super unstable. APIs are unstable. Claude was down for like an hour yesterday. OpenAI was down for like 45 minutes the day before. Tool calls gets down. Like it's still a wonky space. As soon as you start to do like high volume, when you start to do like a couple of 100,000 requests every day, you get like all kinds of weird stuff back. So our degree of monitoring and stuff needs to really sharpen up. And as to your point, all closed source products and APIs seems to be continuously changing, which is like a really frustrating thing. I think and I hope, and maybe I'll learn something more about that today, but I think and I hope that like the open source models of the world are starting to get on par. If we dismiss GPT4o and Claude 3.5, I think you'll see that Llama 3.1 was actually on par with like 4 Turbo and like the previous set of state-of-the-art models. So we started to fine-tune Llama 3.1 to see what we could do with that, with like Grok, which is like a super fast inference layer. It's like super cool. But like, basically, we don't have control over the models, which is a significant part of what we do, which is like mega scary. So it would be super comfortable if we could own the model and own the weights and know when we change things, so we could like sync up when we do like prompt test and test this and tool test and like all that kind of stuff, where we can control the model. that is, I think, my dream. And then lastly, what we really suck at, which I want to get like a lot better at, is this. And here I also think that we can learn something from the people here, in that people in Databutton today, people primarily communicate through chat and through images, which is like, it's all right, but it's like talking to like a consultant on email. So it would be cool as we start to understand more about the structured outputs and how we can like lean more into what the agent really knows well. Can it like start to spawn UIs and spawn like workflows, and like can we get into that a little bit more? Our designer has been wanting to do this for a year, but like everything has like been absolute shit, so it's like pointless. But now I think we're starting to get at the point where this actually makes sense. And I think secondly, our investments in like monitoring and infrastructure for this stuff needs to like dramatically increase, I think. Hopefully some cool SaaS companies will like start and do this like really well, so we can not build this internally because it's expensive, it's difficult, we're 7 people. And then this. I could almost have like a monthly meetup to like compare benchmarks and like open source models and stuff. That'd be awesome. Because this needs to just like get really good. That'd be awesome. And with that, I think my 20 minutes are up. Thank you very much. Are there any questions?
First of all, thanks for the presentation, and I really appreciate the product that you're making, because I built numerous simple websites with Webflow, which is a no-code solution for building the front end, and it saved me, I don't know, dozens of hours. So essentially, it's the next step, and I understand how much it means for some people. I have a couple of questions.
Please.
We actually have time for maybe one question.
Yeah, short. You mentioned that you were experimenting with Llama 3.1. And I checked that it's on the 4th place on the arena in coding.
It is, yeah.
Right now, and I read that fine-tuning
4.0
increases its abilities, so it may be on par with the state-of-the-art closed source LLMs. So, are you planning to explore more into this space? Just because it's an open source.
Yeah. We've fine-tuned, I think, about like 15 models over the past 3 months. As whenever like GPT4o mini came out, fine-tunable, for those who doesn't know. And as of yesterday, I think, or the day before, 4.0 is also tunable. So I think when you start to look at now, like, or maybe tomorrow morning, when you look at not the LLM benchmarks on LLMs, which is what you're referring to, I think, but when you look at like the SWE, like the software engineering benchmark, which is solving real-world GitHub issues, and you're allowed to have like workflows, not just like one call, then I think you'll see that everyone there is using GPT4o fine-tuned. I suspect that is a lot better, unfortunately, now that we've done the Sonnet thing. Yeah.
Okay.
But I do hope that we can fine-tune everything, and meaning that we can fine-tune a reviewer, we can fine-tune a planner, we can like you can start to apply the LLM stuff on like smaller and smaller blocks. Price goes down, we can afford to have twice as many LLM calls, and then that's kind of the route we're chasing. Yeah.
Okay, cool.
Cool. Thank you so much.
Thank you so much.